Phases are the solid, the liquid, and the gas. When the solid, which is ice, melts, it turns into a liquid when the temperature is increased. And when it's increased greatly, the liquid turns into the gas. Notice how in the solid there's empty space in between each of the ice cubes. And notice how the liquid takes the shape of its container. And now you can see how the gas just moves around freely everywhere.
What's the difference between a solid, a liquid, and a gas? Think of these balls as atoms or molecules. And here we have a nice orderly structure as in a solid. If we add energy, the molecules vibrate, but they stay in relative position. So there's kinetic energy, there's motion. If we increase that kinetic energy and give them more, you can see more motion. And now we have a liquid. If we have even more energy, we now have a gas. Let's suppose we have a liquid that is a mixture of two compounds. Let the white golf balls represent ethanol and the blue represent water. And we want to separate them. At this point, you see there are 18 white ethanol molecules and only 4 water molecules. So we're going to heat this up, add energy to it. So as we add energy, some of it is going to evaporate and leave our container. All right, after adding a little energy, now we have 2, 4, 6, 8, 10, 12 white balls and 4 blue balls. So let's try again. Add more energy. All right, now you see there are 2, 4, 6 ethanol and 3 water molecules. You should note that even though what we're trying to do is remove all the ethanol, we also remove some of the water. So when you're trying to distill something, you're not going to get a 100% pure substance.
The changes in these 3 phases.
So I have a beaker of ice. I'm going to place it on this hot plate right here, and we're going to watch as it goes from a solid to a liquid to a gas. Right now it's a liquid. It'll be a gas soon. Look at that, it's all gone. Guess where it is? In the air.
In the air.
Particles of the solid and what they look like. They're very close together, and notice how there's not much empty space in between them. This is what the particles of a liquid look like. They slide past each other in random movements, and that's why they can take the shape of any of their containers. This is what the particles of a gas look like. They're very spread apart and they move freely and they're not contained in
Up a heating curve, those phase changes are endothermic. From solid to a liquid needs to absorb energy, and liquid to a gas needs to absorb energy. And then just the opposite are exothermic.
Time increases and the temperature increases. It's an endothermic reaction going from a solid to a liquid to a gas. The same thing backwards, it's an exothermic reaction that goes from a gas to a liquid to a solid as time decreases and temperature decreases. These straight lines right here, where nothing seems to be going up, is where the phase changes occur. This one right here is melting and freezing from a solid to a liquid or a liquid to a solid. And this one right here is evaporation and boiling.
Kinetic energy is happening from there to there and there to there. When it's like horizontal, it's potential energy, waiting for it to become kinetic energy.